part of our simplex method video. Today we are continuing from where we left from last time. Last time we derived the first table and we were actually in the process of deriving the second simplex table. So this is where we left from last time we met. Now today we are going to finish the simplex problem, and hopefully by the end of this video you will have understood the process of solving a linear, or of obtaining optimal solution, of obtaining an optimal solution using the simplex method as a part of the linear programming problems. Now we all remember how we derived this table. Okay, now in our second part of the video, which we are doing now, our focus will be on the values that we did not find. Okay, the values that we did not enter into this table, and these values are in all the blank spaces that we left last time. Now, how do we go about solving this problem or completing our table? It's really a very simple thing that you must know and you must understand. Okay, so how do we find the value for for S1 and S1, the intersection here? How do you find that value? Okay, or simply put, how do we reduce this 5? Remember, again, I think this is one thing I forgot to mention. One thing about the simplex method or algorithm is it is a reduction process. So with every iteration, you see almost all the numbers in your table, they'll be shrinking down. That is why it's not possible, I think, to go on infinitum when you're solving for the simplex method, because generally, I think for most problems that you notice or that you come across, when you are iterating between tables, okay, or when you're moving from one table to another table to another table, what you quickly notice is that all your numbers in your table are reducing. Okay, and some numbers may actually be entering into the negative realm. For example, especially for the numbers in your table, they may be entering into the negatives. Yeah, but what you must know is that it is a process of reduction. The numbers or the values in your tables, they will be reducing with each and every iteration that you do. So that is what we want to do with the remaining values in our table. So we have the first row, or row 1. So we need to reduce these values in row 1. How do we do it? Now, the thing that you must remember is, for the first formula that we had, and if I can remember, and I do remember, it is R1 minus 6R4. Now, what you must know is this formula applies here, it will apply here, it will apply here, and it will apply here, and it will also apply there. Okay, so what do we do now? What is R4? Okay, sorry, what is R1? R1 is 5. So bring your 5, write 5 here, minus 6 slash, or sorry, not slash, open bracket. What is our R4? Now the R4 is the value that you are going to find in your key row. So the value corresponding to the 0 here in our key row, this will be your R4, your new R4. Not 1, take note, not 1, but 0. So put the 0 there. So what is 5 minus 6 times 0? The answer is 5. So in our new table, you're going to write 5 here. And then you move on. So you skip this because we have already found the 0 for here. And then you come to the 1, where there's 1 here. Now, how do you find the value for, or how do you reduce that one? So the way you reduce the one is the same way we reduced the 5 here. Although it not reduced because there was a 0. So what we do is, what is our R1? Our R1 is a 1. So it will simply be 1 minus 6, open bracket, the value corresponding in the key row. What do we have? We have a 0. So we're going to put a 0 here, and then it will be equal to 0 there. Okay? So that is what we are going to do. We do the same thing. This is a 0. Now this is simple because we have 0 minus 0. Sorry, 0 minus 6 times 0. We have a 0. So we're going to have 0 here. And sorry, did I say 0? No, this should be 1. Yeah, this should be 1 because this is 1 minus 6 times 0. This would be a 1. So let me quickly correct this. So this is a 1. Apologies for that. And then here we said we have a 0. And then S3. So where is our S? So this is our S3. So we have 0 minus 6 times 0. So 0. Then for our S4, we have a 1 here. So let's do this. So we have 1. Sorry, we have 0. Using the same equation, we have 0 minus 6, open bracket, 1. Okay, the value corresponding to 0 in our key row is 1. So this would be 0 minus 6 times 1, negative 6. So we can come here, write negative 6. Okay, then we proceed. Proceed to the last one. What's the last one here? We have 10,000. So we're going to say 10,000 minus 6 multiplied by 1,200. So let me do that on the calculator. We have 10,000, or we have 6 times 1,200. So 6 by 1,200, we have 7,200. Then 10,000 minus 7,200, we are getting a 2,800. So we put 2,800 here. We are done. We come to the next one, which is our SC2, or our row 2. Now if we remember the formula for row 2, it was R2 minus 2. So it was R2 minus 2R4. So we had R2 minus 2R4. Okay? So it's the same process again. 0 minus 2 times 1. What do we have? 0 minus 2. Sorry, 1. That's a 0. So we have, we are here. So we said it's R2, so it will be 1 minus 2, open bracket, 0. This is how it's supposed to be. So this would be 1. Okay, please don't get confused. So it's 1 minus 2 multiplied by the key value here, the 0, the corresponding number in our key row. So this gives us a 1 there. Then we skip the 2, we come to this one. Now here we have a 0, so it will be 0 minus 2 by 0. So we know we get a 0. So we're going to put a 0 here. And then here we have a 1. So it will be 1 minus 2 multiplied by 0. What do we get? We get a 1, of course. So we're going to get a 1 here, like that. Then we come to S3. So here we have 0 minus 2 by 0. We get a 0. So it will be a 0. Then the last one here we have 1. So it will be 0 minus 2 by 1. So it will be negative 2. Okay, so we are going to have negative 2. And then the last one, this one, so we are going to do 3000 minus 2 by 1200. So what is 2 by 1200? 2400. So 3000 minus 1000, sorry, minus 2400, we get a 600. So we are going to get a 600 here. Okay, now once we have done this, then the last thing that we need to do on this table is in our z function. Remember our equation for the z, or for row 4. Let's remove this. Okay, let's do this. Okay. All right. Okay. So for row 5, we said it to be R5 plus 129 R4. So we do the same thing for all of these values. Okay, so we have 80 here, negative 80, so it will be minus 80 plus 129, we open bracket, and then what is your R4? R4 here is a 0, so we have negative 80. So we come here, we say negative 80. Okay, and then here it will be 0, so we put 0 here, plus 129 by 0. So what do we get? We get a 0. So 0 here, then here to be the same thing, to be a 0, here to be the same thing, to be 0, then here we have a 1. So what do we do? So we have a 1 here, so it will be, let's see, so it will be 0 plus 129 by 1. Okay, so 0 by 129 by 1. So we have a 129 positive. So plus C 129 there. Okay. Now, once we have done this new table, we have to check in our objective function, or in our z, do we have a negative? And the answer is a resounding yes. Indeed, we do have a negative value. So what do we do? Again, we say this is our negative value, or the most negative number, or the smallest negative. So we are going to select this as our key column. Once you have selected this as our key column, remember we divide your right hand side over your key column to find the ratio. So what is 2800 divided by 5? So let's see, 2800 divided by 5, so we get a 560. 600 by 1 we get a 600, 600 by 1 we get a 600, then this is nothing. So what is the smallest value? The smallest value here is the smallest ratio, the smallest positive ratio is a 560. Okay, so now we are going to select or circle that, and this will become our key element. Okay, so that will become our key element. Now once we have our key element, remember, colleagues, what we mentioned. I'll be very slow this time around. I don't want to lose anyone. So remember what we said once we have our key element. And this is a good example because our key element is a 5. So we are going to draw another table before we even do anything. Okay, I'm going to do what? I'm going to draw another table, the third iteration. Then in this table we have our basic variables, our basic variable. Then we have our coefficients, the coefficients of x1. Then we have our RHS, our right hand side, and then we have our ratio there. Okay, then let's draw our table there. Then okay, so what do we have next here? We have our ratio, our right hand side. We just do that and that and that. Then once again we just close it there, and then we put our z and then x1. So we have our x1, our x2, our s1, our s2, our s3, and our s4. Okay, and then we start. Now this is a good one because we have a 5 as our key element. So what do we do now? Since we have a 5 as our key element, remember what I mentioned, our key element must always be a 1. So how do we make this key element to become a 1? We must divide it by itself, and when you do that, you must divide in all the other values except the ratio with the key element. So what I mean is you're going to say 5 over 5, 0 over 5, 1 over 5, 0 over 5, 0 over 5, negative 6 over 5, 2,800 over 5. So we're going to have a 1 here, and then 0, and then 1 over 5, and then 0, 0, and negative 6 over 5. And then what's the last one? 2,800 divided by 5. So we have a 560 here. So we have a 560 there. Okay, now please take note that, remember what we said again, that on your intersection, the intersection between your key column and the key row, the corresponding basic variable, which is our s1, becomes redundant. Okay, meaning it is going to be replaced by the variable in the key column, the corresponding variable in the key column if it's an x variable. So in our case here we have x1. So x1 is going to replace s1. So we're going to say x1 enters and s1 leaves. So here we're going to have our x1, then our s1, our s2, and our x1, s2, s1 leaves. So we are only going to have s2 now, and s3 and x2, like that. Okay, now once you have made these elements to be once you have made your key element to be a 1, you must also make the corresponding elements, or the elements down and above your key element, to become zeros. When your key element is made to be a 1, the elements below and above your key element must be made into zeros. Now remember what I said. If there's a key element, or if there is an element in your key row, your key column, sorry, in this column where there is your key element, which is already a 0, in our case this here is a 0, we basically lift the entire row and bring it into the new table. So we are going to lift it and then say 0 here, then we have 1, 0, 0, 0, 1, and 1200, like that. Okay, then we're going to say now that we're going to make our formulas now. Okay, let's see how we're going to do this one. So our formulas will be very simple for this, because here we just have ones. Now we need to make, let's say row 1, row 2, row 3, row 4, row 5. We need to make row 2, row 3, row 5 to become zeros with the help of our new key element, which is a 1, not 5 but a 1. Okay, so it will be, to make 1 to become a negative, to be a 0, what we basically do is we say 1 minus what? Minus 1. Okay, now we are making this one with the help of, we are making 1 a 0 with the help of row 1. So just put row 1 here and put row 2 here, where the 1 we are making, we are turning into a 0 is. Yeah, and I'm using the languages loosely so that people can understand what I'm talking about. Same thing also for this one here. It will be R3 minus R1. Okay, for the last one it will be since that is the negative, so it will be negative 80 plus 80, so it will be R1, and then here we are going to have R5, like that. Okay, so this is what you are going to do. Okay, so here we are going to have 0, 0, and 0 there as your first step. Now once we make those zeros, we can now come to the next part and begin solving for the remaining values. Okay, now how do we solve for the remaining values? It is the same process that we did in the previous iteration. So we are going to say R2, which is a 0 here. So we're going to say, let me just write them here. So what is R2? R2 is a 0 here, so it will be 0 minus 1 open bracket R1 0. Okay, so we are going to have a 0 here, so this will be a 0. Okay, so this is 1 over 5, the new value. Okay, so to be 0 R2, which is a 0, minus 1 multiplied by 1 over 5. What are we going to get? 1, negative 1 over 5. And then here we have 1. So it will be 1 minus 1 by 0. Remember, we are basically using the formula, so don't be confused. Okay, we are still in row 2 and using the formula for row 2. So R2, where there's R2, put a 1, so it will be 1 minus 1 open bracket 0. So we are going to return our 1 there. Then here we say 0 R2 minus 1 multiplied by 0. So what we get? We get the 0 there. The last one is the negative 2. Okay, so for negative 2, let's try to solve it. So it will be negative 2 minus negative 2 minus 2 minus 1, sorry, open bracket, negative 5 over 6. Yeah, so let's solve this. So this would be positive. So it will be negative 2 plus 6 over 5. So we can say negative 2 times negative 2. So this would be minus 2 by this. So this would be a 10. Yeah, so it would be a 10. Then 10 minus 6 over 5. So it would be 4 over 5. So we're going to have negative 4 over 5. Yeah, so we're going to have negative 4 over 5. And the last one is 600 here. And the new value, which is 560. So what is R2? 600 minus 1 by 560. So what do we get? We get a 40. So we get a 40 here. Okay, then we come to the last one. We come to the not the last one, the second last one, our R3, our third row. So we're in the third row. So this would be 0 minus 1 by 0. So here, so to be 0. So let's put our 0 here. Please rewind, rewatch this video again. Feel free to pause, ponder upon a step until you get it right. Okay, so then we continue. So this is 0 again. Here we're here 0 minus 1 open bracket 1 over 5, you close bracket, and then we get a negative 1 over 5. So here also it will be negative 1 over 5. And then here we have 1 minus 1 open bracket 0, this 0 here, then you close bracket. We're going to have our where are we? Oh, we are here. Sorry. I think I made a mistake. We are here, yes. Yeah, so yeah, so we are here. So this is 0 minus 1 times 0. So we get a 0 here. So we put our 0 there. And then here we have our 1. So it will be 1 minus 1 open bracket, then what is R1? R1 is 0, so it will be a 0. And then the last one is what? 0 minus open bracket negative 6 over 5. So this will be positive 6 over 5. So it will be plus 6 over 5. Then the last one now. The last one is this value here. So what is our new value? Our new value is 560. Yes. So keep the 560 in mind. So this one would be, what is R3? What is R3? Our R3 is 600 minus 1 multiplied by 560, the new value here 560, so it'd be 600 minus 560, which is 40. Okay, now we come to the last one, the R5. So this is a 0. So our R5, what is the formula for R5? We said it's R5 plus 80 times R1. So R5 is 0, so put 0 plus 8 times R1. R1 is what? The new value here, which is 0. So it will be 0. So we're going to put our 0 here, like that. Okay? And then we come to the next one. So we have 0 plus 80 multiplied by 1 over 5. 1 over 5. So 80 into that. Let's do this. 1 over 5. So we are getting a 16. Okay, so I'm getting a 16 at least on my end. So this will be a 16 there. And then here we have 0 and 0, so it will be 0 simply. And then 0 and 0, so this also will be a 0. And then the last one, this is 129, so let's write 129 plus 80 multiplied 80 by 6 over 5, negative 6 over 5. So what is 80 multiplied by negative 6 over 5? So it's 96. So it will be 129 minus 96. So 129 minus 96. So we're getting a 33. So 33, please counter check the numbers. I hope they are correct. So yes, we have no negative now here, which is good. So we have no negative. What do we do now? What we do is simple. We're simply going to say x1 is equal to, we get the x1 here and the x2 here. Then we get the right hand sides for the x1 and the x2. So x1 is equal to 560, x2 is equal to 1200. What about our z function? Now since we have our x1 and x2, just say z is equal to, remember our first equation, our objective, 80, put where there's x1, put 560, then say plus 129, put 1200, and then say this is equal to, what is 80 by 560? 44,800 plus 1,200 by, 129 by 1,200. So we're getting a 154,800. So 154,800 plus 44,800. We're getting a 199,600. So in the exam, you're going to say therefore x, so optimal solution is equal to x1 is equal to 560 colon, x2 is equal to 1200, and z max is equal to 199,600. So ladies and gentlemen, this is the solution. It means that for our company to be able to maximize profit for the PCs which they must produce, they need to produce all the 1,200 XPs. and they must only produce 560 X1s or basic computers to get an optimal profit of 199,600. So this is how you optimize, or this is how you find the optimal solution using the simplex method. Once again, thank you very much for watching this video, and see you in another video. Thank you very much and have a good one.